Okay, welcome back to Physical Science Online Lab. Today we have a fun but complicated one. We have a gravity lab. We're actually going to be exploring gravity. And just to warn you up front, some of this lab is pretty complicated. Some of the equations are way harder than we will cover in class, but it's still a really cool lab. And I have tried to help you with the calculations by providing, once again, a calculator that Google Sheets that's attached that will let you do everything. So if some of it looks a little crazy, if some of it seems a little crazy, don't get too freaked out by it. Things aren't going to work out perfectly today, and some of the stuff will go just right over some of our heads. It's okay. It's okay. This is meant to be a deep thinking lab. But I think you can still fill in the data, use what we have here, use what we do in class if you're lucky enough to be in class, or this video in order to do everything that you need to do for full credit and for a deep enough understanding of the force of gravity. I'll keep coming back to that. That's what our videos kept coming back to that you did before you started this. Force of gravity. Gravity is a force, but it's a unique force because it causes a uniform acceleration, which means that the force it applies has to change. So if you understand anything about gravity, it has to be that the force that's applied depends on its mass, the mass of the object that's getting pulled down due to gravity. It actually changes the force. If you cut the mass in half, change the mass, the force that is applied will change, and then the acceleration will stay the same. So you can read through that. Of course, the first page is just intro and what's going to actually happen. Then I wanted to give you a demonstration for part one here of what you would do in class. So in class, you would actually set up a little grid along the wall using meter sticks, and you're just dropping objects. So you'd have either you or your partner. You can do this one alone, but it's always easier with a partner. Would use a watch or your phone, and you would time how long it takes from when you drop it to when it hits the ground. Now with video recording, like we proved with the airplanes, that makes it a little bit easier if you have a video that goes down to that many point whatevers of a second. In class, your challenge is to time that correctly from when that person releases to when it hits the ground. The timing aspect, the human error today is very high in this lab because nothing's perfect. And it happens so fast. We're talking, if you do a 0.5 meters, you're talking way less than a second. Even from 1 meter, we're less than a second, and trying to time that perfectly does lead to some problems. But that is what you would do in part one. You would get your times from different heights. You'd do it a few times to get an average. So you'd probably do 1 meter 3 times just to get an average, like we do in science every time. It helps with that human error a little bit. And then you would come back to your data sheet here. And we are not filling this in on Google Docs today. Instead, you would fill it in your gravity calculator. If you aren't able to do this from home, you aren't able to get your own data, you can use my data from previous years. It's fine. It works. If you are already able to do this in class, you would also, almost forgot, you would also mass your object using the scale in class. That'd probably be the hardest part to do at home. So those of you that are at home probably will end up using the data above the gray line. Those of you in class definitely will try to use the data below the line, use your own data. Think I'm running short on time already, so I'm going to end this video for part one, and I'll do a second video for part two.